Today we are going to speak on differentiation. What exactly is differentiation? So let's start with our distance time graph. This is distance and this is time. Suppose you want to go from CSMM, the Creative School of Maths and Music, which is situated at say X1, to Connaught Place. It is situated at X2. You move along. Suddenly near Janpath, you meet a friend. So you chat with him. Then finally, you reach Connaught Place. This you start with say time t1 and you reach Connaught Place at time t2. So what is your average speed over this whole journey? The average speed will be x2 minus x1 by t2 minus t1. So x2 minus x1 by t2 minus t1. But see, this information doesn't really tell you that you stopped in between. There was a smooth drive, no traffic. Again, there was a smooth drive. There was no traffic. If you want to change it, some traffic, it becomes a curve like this, and so on. These small informations that happen within this frame is not taken care of. So how do we address that? We address that by trying to find out the same average over a very small time interval. Suppose I take a very small time interval. Call this t1 prime, call this t2 prime. And of course, the distance covered in this time is x2 prime and x1 prime. So this length is x2 prime minus x1 prime, and this length is t2 prime minus t1 prime. Now my average over this will be a much smaller average. So now I have some understanding over my average speed in this interval, which if I shift, now I can control it. But if I become more greedy, I want it exactly at certain points. So what will I do? I will make this interval small. As I make this interval small, I will get what I call the instantaneous velocity, which is basically x2 prime minus x1 prime by t2 prime minus t1 prime with the limit t2 prime tending to t1 prime. Very small t2 prime tending towards t1 prime. This is also said as dx dt. That's the official definition of derivative. Now this is for the distance time graph. Now we will extend this to more general functions. We have got a function fx and x. And let the function be like this, moving like this. I choose a point. over here. I want to find the derivative around this point. What will I do? I will draw a tangent at this point. Then, let this point be my x and this point be my x plus h. I should try to do it symmetrically. So I will just extend it a little bit. For the time being, I'll rub off this. So this width is my h. And what is this? This point is my f at x. And this point is at f at x plus h. So this length is f at x plus h minus f at x. This length is f at x plus h minus f at x. So, what is the slope? Means the tangent. Delta f, delta x, that's what I will call the change in f over change in x. That's nothing else but f at x plus h minus f at x by h. But these are all finite distances. Now, as I said, I would like to 3D. So I would like to shrink this. I want exactly at this point. So I would like to shrink this further and further and like this. Smaller and smaller and smaller. So what's the mathematical way of writing that? Limit h tends to 0, f at x plus h minus f at x by h. Limit h tends to 0, delta f, delta x. And that is nothing else but the derivative. This is the formal definition of derivative, which measures the change in the function over the change over x as this distance h tends to 0. That's your definition of derivative. Now we'll use this concept to find derivative of a few known functions. Let's try fx as x to the power n. Like the definition, df dx is limit h tends to 0, f at x plus h minus f at x by h. So f at x is x to the power n. F at x plus h is x plus h to the power n. I'll use that. So x plus h to the power n minus x to the power n divided by h, limit h tends to 0. That is my derivative. I've used that. So that is nothing else but I expand this to binomial expansion, which is x to the power n plus n x to the power n minus 1 into h plus n into n minus 1 x to the power n minus 2 h square by 2 factorial and so on, minus x to the power n divided by h. Well, this division line is not that straight. Sorry. So this thing and this thing will get cancelled. Now see, all these terms contains at least one h. So I can take out h. I'll be left with n x to the power n minus 1 plus n into n minus 1 x to the power n minus 2 into h by 2 factorial and so on divided by h. I'll cancel this. Now I'll put the limit. All these terms contains h, so they will all cancel. Only this will remain, and that is nothing else but n x to the power n minus 1. So we get our first result. If this is the case, then df dx is n x to the power n minus 1. Now we will apply this principle to another function, say sin x. Again, f of x plus h will be sin of x plus h. Using that, df dx is limit h tends to 0 sin of x plus h minus sin of x by h. Now sin c minus sin d we know is 2 cos c plus d by 2 sin c minus d by 2. Use this over here. So I get 2 cos c plus d by 2 sin c minus d by 2 divided by h, which gives me 2 cos x plus h by 2. This thing gets cut, sin h by 2 divided by h. Now we will use another standard result of limit h tends to 0 sin h by h is equal to 1. But here I have got h by 2 over here and here I have got h. So I cannot use that. Okay, I can use that. I will make this also h by 2 and multiply by 2. Now I can use this. So if I take the limit, 2 gets cancelled. This is 1, this is 0. So I get cos x. So I finally get the result. If this is the case, then df dx is cos x. Finally, I will end today's video with the function base x. Now, again, f of x plus h I will write because I need that from here, which is log base x plus h. Use the formula. So df dx is limit h tends to 0 log x plus h minus log my fx by h. Now we know that log any base x minus log same base y is log x by y. So log x minus log y, so I will get log of x plus h by x whole thing by h. So if I simplify this, I will get 1 plus h by x. Now we did in one of our Taylor series expansion, the expansion of log 1 plus x is x minus x square by 2 plus x cube by 3 and so on. I'll use it over here. What do I get? H by x minus h by x whole square by 2 plus h by x whole cube by 3 and so on divided by h. I'll take h out. I'll be left with 1 by x minus h by 2x square plus h square by 3x cube and so on divided by h. This gets cancelled. All terms contain h. So I'll be left with only this term, which is, after taking the limit, 1 by x. So we get that's all for today.